So next it says, when combining two or more functions to create a new function, always be sure to determine the domain of the new function. It says, notice that this is actually example 2C from the book. The function p divided by n is not defined for x equals -1, right? Because that would give you 0 in the denominator of that fraction, or also 3, because that would give you 0 in the denominator of that fraction. So we do need to consider domain. So on example 3, hey, let me color code these again. R of x is going to be equal to -3x. That function has no domain issues by itself. P of x equals x squared plus 3x. That function has no domain issues by itself. All right. Q of x, with that square root, we're going to need to make sure that the stuff underneath the square root stays positive or 0. So on number 20, it says to find the indicated function and write the domain in interval notation. Let me get some paper set up here. Okay. And so P minus R evaluated at x means to calculate P of x, and from that we are going to subtract R of x. Now you notice it just says of x on each of these, and so there's really no number crunching to do. What we are going to replace P of x with is what P of x is equal to. That is the x squared plus 3x. And from that, we are going to subtract. Now, I think it's a good idea to go ahead and put things that you're subtracting in parentheses so that just in case you need to run the negative through to multiple terms, you're ready to do that. But R of x is equal to a -3x from right up here. And so really all we need to do is clean up and give our final answer and then express the domain. But x squared plus 3x, and this would actually be plus 3 more x, will give us x squared plus 6x as our newly created function, P minus R. And up here on number 20, they could have just said calculate P minus R. And that would have meant, oh, they mean P minus R evaluated at x. Okay? Now we need to talk about the domain of this function. Let's see, I'll do domain in red, I'm filling. So the domain of this function is the set of all values for x for which the function is defined. Okay, it's undefined when we get 0 in the denominator or a negative under an even indexed radical like a square root, fourth root. So really here the domain is all real numbers, all reals. Oh, but they said to write the domain in interval notation, so we probably need to say -infinity to +infinity. There's our domain in interval notation. Over here on number 22, they want us to calculate R of x, and we're going to, as our operation, multiply that by Q of x. All right, so go put that in. R of x is -3x, and we are going to multiply that by Q of x, which is equal to the square root of 1 minus x. Now, when we multiply that together, the best we can do to simplify that for R times Q, the new function, is we will say that's just going to be -3x times the square root of 1 minus x, right? The operation in between this x and the radical is understood to be times when we write it like that. So there is our newly created function, R times Q. And now what we need to do is determine the domain. Okay? On this one, for domain, we're going to have to exclude values of x that will give us a negative quantity under that radical. In other words, we want to ensure that 1 minus x stays greater than or equal to 0. Remember how we tackle the domain on something like this? So our next step is to solve this little inequality for x. And I think the easiest way to do that is to add x to both sides. So we get 1 is greater than or equal to x. And another way to write that is to say x values need to stay less than or equal to 1. There's our domain. All the x values that are less than or equal to 1. And so those numbers expressed in interval notation is everything from negative infinity up to and including 1. That's our domain. Now, if you want to come back up here to your newly created function and say, well, yeah, as long as x values are less than 1, like if it's a 2, that's not going to work out because 1 minus 2 is a negative 1, and you have a square root of negative 1, and that is I. That's an imaginary number, not a real number. But if those x values stay less than 1, such as negative 2, what we get underneath the radical is square root of 1 minus a negative 2, which is 1 plus 2, or 3. That's good. That's a good little real number. Okay? So that's why we need to make sure that our radicand stays positive or 0 for these even-indexed radicals. Remember that?